Algebra 2 trig, sample question number 4. The solutions to the equation negative 1 half x squared equals negative 6x plus 20 are what? So this is a multiple choice question, obviously. There's a couple ways to solve this. So the first start is let's clean it up a little bit. Let's set it equal to 0. Let's get it to one side and kind of see what it looks like there. So if we set it equal to 0, we have negative 1 half x squared, and then we'd have to add 6x to the left, and we'd have to minus 20 equals 0. And I can't solve for x when I have an x squared term and an x to the first term, which means typically, in early stages of algebra, that meant you had to factor. But this is not going to be something that's factorable. And also, look at our answers here. It's either going to be imaginary or irrational, which tells me that I'm going to have to use a formula here, the quadratic formula, or I could do the procedure for completing the square. Whatever you're more comfortable with, the quadratic formula is usually probably a little bit easier, and that formula is actually given to you on your reference sheet. But before I do the quadratic formula, I would still clean this up further. I don't like this here. That's really what makes it kind of an unattractive question. It makes it look difficult that you have a negative 1 half coefficient. And so we've learned that anytime we have a denominator we don't like, we can multiply it out. We could clear that denominator out to make the problem a little bit nicer to work with. So I could multiply out 2, but I could go even further. If I multiply negative 2 everywhere, that will leave me with a positive x squared here. So that's what I'm going to do, is I'm going to multiply everything by negative 2. So times negative 2 times negative 2 times negative 2. This way, negative 1 half times negative 2 really eliminates itself to a positive 1, so it's just x squared. And it's much better working with trinomials when we have a positive x squared, especially a 1x squared. So that's just going to make my life a little bit easier. So if I multiply that out, then I multiply the other expression. 6 times negative 2 is negative 12x, and negative 20 negative 2 is positive 40. And at a quick glance here, it almost looks like it can be factored. It's not a really complicated looking trinomial anymore. So you think, all right, what multiplies to 40? But they also need to add to negative 12. You think, all right, we got 4 and 10, but they don't add to 12. 5 and 8, they would add to 13. But there's just not a number that's working out here. So you could think about the factors, and you could certainly look at the factoring possibilities, but you're going to realize here that this is not a factorable expression. And so that's where I'm going to use the quadratic formula when that happens. And that's really what these formulas are for. If it's factorable, I'm just going to factor it. But if it's not, then I'm going to do quadratic formula or completing the square. And maybe I'll show both examples here if we have enough time. So the quadratic formula, as I said, this formula is given to you, so you don't need to memorize it, which is nice because a few years ago you did have to memorize it, but you don't anymore. B squared minus 4a times c, and that is all over 2a. So a is 1, it's coefficient of x squared, b is negative 12, and c is 40. So if we substitute this in here, let's see what happens. So negative b would be positive 12, right, because it's negating that. Plus or minus b squared is negative 12 squared, and that's b squared is always a positive value, right? Because whether b is positive or negative, when you square it, it's going to be positive either way. 12 squared is 144, so is negative 12 squared. So that's your b squared term should always come out to be positive. And then it's a minus 4 times a, which is 1, which doesn't do anything, and then times c, which is positive 40. And this is all over 2a, which is just 2 times 1, so 2. A lot of people like to use their calculators in here and just type that all in to get that piece there. I'm going to try to do this without a calculator. So 12 plus or minus the square root of, this would be 144 minus, now negative 4 times 40 would be minus 160 over 2. And automatically right here, I'm realizing that this is going to be negative, and that means I'm going to come out to be something with an I. So that's kind of a clue right there as to what's going to happen. X equals 12 plus or minus, that is negative 16 over 2. That's 12 plus or minus the square root of negative 16 is 4I over 2. And then I can divide everything here by 2 to get x equals 6 plus or minus 2I. And that is why our answer there is choice number 3. Let me show you real quick how to do completing the square process with this. Given a choice, I'd probably do quadratic formula here, and I think a lot of people would, especially since you're given the formula. But for completing the square, what we would do is we would first set it equal to the constant, the plus 40 that goes to the other side. And then we add something to both sides. What we add to both sides comes from our b term divided by 2 n squared. So dividing it by 2 is negative 6. Squaring it is 36. And so that's negative 40 plus 36. And so we add something to both sides, and that comes from the b term divided by 2 squared. And that's the one step students forget a lot. Then I factor it to x minus 6 squared. And that's why it's called completing the square, because factoring this, it's factorable, and it's a binomial square. It'd be x minus 6, x minus 6, numbers that multiply to positive 36 adds to negative 12. Negative 6 multiplies to this, adds to this. So it's always a binomial squared, and the shortcut is it's just your b term divided by 2. But there we see that, and then we clean this up over here to be a negative 4. And then we square root both sides. And when I square the root with this, square root this, square root, the squared cancels each other out, so x minus 6 and the square root of negative 4, but we got to remember to put a plus or minus when we square root both sides. Square root of negative 4 is 2I. Lastly, add the 6 over 6 plus or minus 2I. So we see we do get the same answer both ways. Completing the square gets a little tricky when this is not even, because you have to divide it by 2 and square it. So if that were like 13, this would end up with some pretty annoying fractions. That's why quadratic formula is probably a little bit safer, again, because you're given the formula on the test. But, you should be familiar and comfortable with both methods, because there have been questions in the past where they will kind of show you, completing the square like halfway through and basically say, like, what's the next step kind of thing, or where did Johnny go wrong in the process, kind of stuff like that. So you want to know both, be familiar with both, but they both essentially do the same thing for us, and that's solve a quadratic that can't be factored. Find the roots. And in this case, because the roots are imaginary, that means we would have a picture of a quadratic that's not hitting the x-axis. It would be something like that. Where are the roots? Where is it hitting the x-axis? It's not. So we say that they're imaginary, and that's what that I represents. So it hits the x-axis 0 times. There are 0 x-intercepts. It's just imaginary. So that's what's happening here. It's a lot of graph structure, but a lot of quadratic stuff. Definitely expect to see something involving quadratic formula, completing the square, simplest radical form, imaginary numbers, things like that. Big major concepts here in one question involved in Algebra 2. So definitely make sure you understand this really, really well. All right, so this is Algebra 2, Regents state sample question number 4. See ya.